Welcome back to Math 109, Plane Trigonometry. In this video, we're going to talk about the standard position of angles and then finding coterminal angles. So we'll start by talking about the standard position of an angle. If I draw a coordinate plane, I'm always going to draw the angle so that my vertex is at the origin. And then one ray of the angle is going to be along the positive x-axis. And then I will go counterclockwise in the direction. So say I want to graph a 200-degree angle. So if I go up, the y-axis is going to be 90 degrees. Going around, the negative x-axis is going to be positive 180 degrees. So I go another 20 degrees beyond that. And I can draw a line there. That would give me an angle of 200 degrees. So the first thing I'm going to do is draw that line on the positive x-axis. Then I'm going to go counterclockwise, however many degrees I need. Now if I have a negative, I'm going to be going clockwise to the absolute value of it. Then I draw a line there. So let's look at a different example. I'm going to draw a angle with 45 degrees. So I draw my coordinate plane, my line along the x-axis, my line at 45 degrees. And just to make it clear, I'm going to put an arrow there showing what I'm doing. Well, now suppose instead of 45 degrees, I want an angle of 405 degrees. So I keep on going. So there's 90, 180, 270, 360, and then I've got another 45 left to get to 405. So I'll cross over, and interestingly enough, I end up at the same spot. So this is what we call coterminal angles. Just means that the terminating edge, which is the edge that's not our initial edge along the x-axis, is the same for both of them. And if I look at 405 minus 45, I get 360. I will always, whenever I have two coterminal angles, get some multiple of 360. So a problem that you might see would be I give you an angle of 530 degrees. Let me just clean up that zero a little bit. And I want you to find the least positive and greatest negative coterminal angles. Now, whenever you see a problem like this, technically any angle is coterminal with itself. However, MyMathLab will not accept that as an answer, so if it gave you something like 45 degrees, you can't say the least positive coterminal angle is 45 degrees. You would need to say 405. So, I'm going to take my 530. I know that a coterminal angle has to differ from it by some multiple of 360. So if I subtract 360, that's going to give me a coterminal angle and that has a measure of 170 degrees. I can now play this game again, take my new angle of 170 and subtract 360, and I get negative 190 degrees. So it turns out that the least positive coterminal angle is going to be 170 degrees. And then my greatest negative which I'll circle in green, is going to be that negative 190. So by doing stuff like this, we can always find a coterminal angle between 0 and 360 for any angle. So if we go back to the coordinate plane and look at standard position, we'll recall that the coordinate plane is divided into 4 numbered quadrants. One, 2, 3, and 4, with 1 being upper right, and then we number around counterclockwise from there. So if an angle theta so we're going to say 0 is less than or equal to theta is less than or equal to 360, all these in degrees. So if it's in the first quadrant, you're going to have 0 less than theta less than 90. Note that we can't have less than or equal to because that would be on the axis and therefore technically not in the quadrant. Likewise, in the second quadrant, 90 less than theta less than 180. In the third quadrant, 180 less than theta less than 270. And finally, the fourth quadrant, 270 less than theta less than 360. So using that, we can find a coterminal angle for any angle between 0 and 360. And now we can use these angles to determine what quadrant that terminal line is going to be in. So this is it for section 1.1. We'll move on in the next video to section 1.2, where we will start talking about some different properties of triangles.